Welcome to the deep dive. Today, we're jumping straight into a really iconic piece of gear, the Korg SQ10 analog sequencer.
That's right, a classic.
And we're not just talking about playing back notes here. We're looking at how it shapes sound at a fundamental level using the original user manual as our guide.
Yeah, and the goal is really to give anyone interested maybe in sound design, maybe electronic music history, or just curious tech heads, a solid grasp without getting totally lost in, super technical jargon.
Exactly. So the manual kicks off by describing it as a, let's see, 12-step, 3-channel voltage-controlled clock generator. Okay, that's a mouthful. What does the 3-channel part really mean for someone using it?
Well, that's kind of the core of its power, beyond simple note sequencing. It means for every single one of those 12 steps, the SQ10 puts out 3 separate control voltages simultaneously.
3 voltages per step. Okay.
Yeah. And if you've got it hooked up to something like, say, a Korg MS-10 or MS-20, like the manual suggests,
Right, the compatible synths.
then you can use those 3 voltage streams to control different things at the same time.
So not just pitch.
Definitely not just pitch.
Mm.
You could have channel A controlling the pitch. Maybe channel B is changing the filter cutoff, the tone color or timbre.
Mm-hmm.
And maybe channel C is controlling the volume or perhaps modulating something else entirely.
Wow, okay, so you're programming the pitch, the brightness, the loudness, step by step.
Exactly. You preset those levels for each step.
Uh-huh.
Imagine the kind of complex, evolving sounds you can build just within that 12-step sequence. It's way beyond a simple melody.
That really opens things up. Now, you mentioned it's also a voltage-controlled clock generator. That sounds important for the rhythm side of things.
It absolutely is.
Yeah.
The clock is basically the engine driving the sequence forward step by step. There's a clock speed knob right on the front.
For tempo.
Yep, sets the basic tempo.
Yeah.
And there's a little LED flashing away, showing you the speed, even if the sequence isn't actually running.
Standard sequencer stuff, makes sense. But then the manual talks about these external clock speed control inputs. Linear in by 2 volt, 2 volt. What's going on there?
This is where it gets really interesting rhythmically. The linear in lets you feed it a voltage, say from 0 to plus 5 volts, to smoothly change the tempo up or down from where you've set the knob.
Like an accelerando or a ritardando.
Kind of, yeah, but voltage controlled. Now, the 2-volt input, for every volt you feed into that, the clock speed doubles.
Seriously.
So 1 volt is twice as fast, 2 volts is 4 times.
Exactly. And the 2-volt input does the opposite. Each volt halves the speed. So 1 volt makes steps twice as long, 2 volts makes them 4 times as long.
Okay, hold on. So you could potentially patch like another sequence, maybe even from channel C of the same SQ10 back into these clock inputs.
You absolutely could. That's the beauty of voltage control. You can sequence the tempo itself, create these really dynamic, shifting, rhythmic patterns that aren't just metronomic. Rhythm becomes another programmable layer. That's pretty wild for a piece of gear from that era. So
Yeah.
how do you actually, start and stop the thing or move through the steps?
Well, you've got the basic start-stop button for letting it run automatically using the clock,
Right.
and a step button to just manually advance 1 step each time you press it. Good for programming or performing specific hits.
Okay. And the external switch control.
That input lets you plug in something like a foot switch. Depending on how things are set up, you could use it to step through the sequence manually with your foot, or maybe to start and stop the clock sequence. Super useful for playing live.
Gives you hands-free operation. Nice. What about shaping the sound between steps? The manual mentions portamento and duty knobs.
Yeah, so portamento A and portamento B glide between the steps for channel A and channel B respectively, instead of jumping instantly from one voltage level to the next.
It slides, like on a synth keyboard.
That kind of effect. Smooth transitions, great for pitch glides, obviously, but also cool for smoothly sweeping a filter or something.
And duty, what's that controlling?
The duty knob adjusts the length of the trigger pulse that gets sent out with each step specifically from the multiple trig out.
Okay, the trigger pulse length. How does that affect the sound?
Think about triggering an envelope generator on your synth. A shorter duty cycle means a shorter trigger pulse, which might give you a sharper, more staccato sound because the envelope starts and might finish quicker within the step's time.
Ah, right.
A longer duty cycle holds that trigger on for longer within the step. This can create more legato phrasing or ensure an envelope has time to complete its full attack decay sustain phase before the next step's trigger arrives. It affects the articulation.
So more control over the feel of the sequence.
Yeah.
Now, about those outputs, we have the main channel A, B, C voltage outs, But also this multiple trig out and then individual trig out, 11 and 12 jacks. What's the difference?
Okay, so channel A, B, C outs send the main control voltages we talked about, pitch, filter, whatever you've assigned.
Oh, right.
The manual notes you can even connect A and B in series for like a wider voltage range. The multiple trig out sends out a single consistent trigger pulse at the start of every step. That's your basic clock pulse out, good for syncing other gear or triggering envelopes consistently.
Gotcha. One pulse per step.
Yep. But the individual trig out jacks, one for each of the 12 steps, are really powerful. Each jack only sends out a trigger pulse when the sequence actually lands on that specific step.
Oh, okay. So step 3 only fires when the sequence is on step 3.
Precisely. And this opens up some cool tricks.
Like the manual mentions, patching one of those back into the reset in jack.
Exactly that. Say you only want a 5-step sequence. You patch the trig out from step 5 into the reset in. As soon as the sequence hits step 5, that trigger pulse forces it to jump back immediately to step 1.
Instant short sequence loop. Very clever.
It's a classic analog sequencer technique. And you can also use those individual triggers to fire off different drum sounds or trigger events on separate synths, only at specific points in the sequence. Think complex rhythmic interplay.
You could build really intricate patterns that way. What about the range switch and those voltage-controlled knobs?
The range switch just lets you choose if channels A and B output a smaller voltage swing, plus or minus 1 volt, or a larger one, plus or minus 5 volts.
Why would you need different ranges?
Well, some synth inputs are more sensitive than others. For fine control over something like filter cutoff, maybe the plus minus 1V range is better, gives you more precision.
Yeah.
For controlling pitch over several octaves, you'd probably need the wider plus minus 5V range. It's about matching the signal to the destination.
Makes sense. And the knobs.
Those are the actual potentiometers, one for each channel on each step. That's where you dial in the specific voltage level you want for that step. The manual suggests stopping the sequencer, using the step button to go to the step you want to edit, and then just turning the knobs for channels A, B, and C to set your desired pitch, timbre, volume, etc. for that moment in the sequence.
Right, the hands-on programming part. The manual also briefly mentions an analog mixer section.
Yeah, it's a simple DC voltage mixer, useful for, say, taking the main sequence voltage from channel A and adding a small, precise offset from channel B for fine-tuning. Or you could potentially link multiple SQ10s together in series, feeding the output of one into the mixer the next to create longer sequences, like 24 or 36 steps.
Extending the sequence length. And one last practical note, the power switch and warm-up time.
Ah, yes. The manual specifically recommends letting it warm up for about 10 minutes after you switch it on. Like a lot of vintage analog gear, the circuits need time to stabilize thermally for the voltage outputs to be really accurate and consistent.
Good tip for anyone actually using one. So the manual gives examples too, right? Basic note playing, but also something about tone color changes.
It does. One example is just setting up a simple 12-note repeating melody using an MS-10, which is the most basic application.
Standard sequencing.
But another, more advanced example talks about using keyboard input to trigger a 24-note sequence, probably using 2 SQ10s or a mode setting, where the sequence isn't controlling pitch, but changing the tone color with each new note played on the keyboard.
So every time you hit a key, the sounds timbre evolves through a programmed sequence.
Exactly. It shows how you can decouple the sequencer from just pitch and use it to animate other aspects of the sound, adding a whole other layer of expression.
Okay, so wrapping this up then, it feels like the big takeaway from the manual is that the Korg SQ10 was designed to be way more than just a simple note player.
Absolutely. It's a deep controller for synthesized sound.
Right.
The 3 channels per step, the voltage-controlled clock, those individual step triggers, it all points towards creating complex, evolving patterns, both melodically and rhythmically.
It offers this really granular control over the core elements of the sound, step by step.
Yeah, and that ability to manipulate not just notes, but also timbre, volume, and even the rhythm itself in real time or via pre-programming is what makes it such a powerful tool for experimentation.
It really makes you think, even with all the digital tools we have now, how much these core concepts of analog voltage control and sequencing still influence music tech. You see the DNA of things like the SQ10 in modern software sequencers, modular setups.
For sure. The fundamental ideas haven't really gone away, they've just evolved. Understanding how something like the SQ10 works gives you a great foundation for thinking about sequencing and sound design, regardless of the tools you use.
Definitely something to chew on how these foundational ways of shaping sound and rhythm persist. Well, hopefully this deep dive gave everyone a clearer picture of what makes the Korg SQ10 tick based straight on its own manual. Thanks for joining us.